to series lectures of basic electronics. Today we are going to discuss about new chapter, which is chapter number 6, digital circuits. So this is most important chapter. So here we are going to discuss about logic gates. So let us start with gates. So digital circuits, it is also known as logic circuits, which carries out a logical operations. Truth table indicates circuit's output, and it will be some logical operation using combinations of inputs. That means if we applied input through this truth table, we can solve or we can get appropriate output. So that means it is truth table. Digital circuit is a circuit where the signal must be one of two discrete signals. Each level is interpreted as one of two different values, like we can say 0 or 1, true or false, or on or off, if it is connected to the analog circuit. So digital systems said to be constructed by using logic gates. So gates are most important for digital circuits. Logic gates. So here we can see logic gate is in an electronic component. Gate is basic building block of digital circuit, and it is used to implement Boolean function. So classification of gates, it is divided into three parts as we can see here. First one is basic gate, number 2 is universal gate, and last one is derived gates, or we can say other logic gates. So we will start with first logic gates. So here we can see logic gates is divided into three parts. Number 1, AND gate, OR gate, NOT gate. So there are three parts of logic gates: AND gate, OR gate, and NOT gate. So these are the basic gates. Second one is universal gates. It is divided into two parts: NAND and NOR. So NAND and NOR are universal gates. And last one is other gate, or we can say special gates, or we can say derived gates, which are XOR, XNOR, which is known as exclusive or exclusive NOR. So in this lecture we are going to discuss about only this gates operation, its Boolean expression, along with its truth table. So let us start with basic gates. So first, basic gates, it is divided into three parts: NOT, AND, OR. So we are going to discuss about NOT and OR's Boolean expression and its truth table. So we have to understand first what is Boolean expression. Boolean expression is the mathematical equation which derived the relationship between input and output, which is known as Boolean expression. So through this Boolean expression we can derive truth table. So here we can see first one is NOT gate. So here we can see this is the symbol of NOT gate, which is similar to the diode, and arrows ahead we can see there is a circle which is known as bubble. It represents, it invert the inputs value. So here if I entered whatever value, we will get inversion of that input. That's why here bubble is represented. So this is the symbol you can see here. Number 2, there is a Boolean expression. So if I entered, for example, A in input side, then obviously I will get A complement. That means it is inversion. So its Boolean expression is like C, or we can say output is equal to A bar. Here we can see this is the Boolean expression. Now and last we can see here this is the truth table. So this is the possibilities. This indicates possibilities of various input to output. Here we can see if I enter at input side 0 value, then I will get 1. So remember this thing, this is the digital circuit, so we have to provide inputs value in binary numbers. So it should be 0 or 1. So I entered 0, I will get 1 at the output side. If I entered 1 value, then I will get 0 at the output side. So it is known as truth table. So this is the NOT gate along with symbol, Boolean expression and its truth table. Next one is AND gate. So here we can see this is the AND gates symbol. Here we can see that there is a symbol and we connect two input. So inputs should be 2, 4 and 3, but not 1 only. 1, that means A and B is equal. That means there is a 1 input. So here this is the AND gate symbol. Now what is the Boolean expression? AND gate represents the multiplication of two inputs. That means its Boolean expression is like output is equal to A into B. So we can make truth table to its inputs value. So here we can see this is the truth table. If I enter 0, 0, that means A is equal to 0, B is equal to 0 and its multiplication should be 0. So I will get in output side 0. If I entered 0 and 1, 1 and 0, because its multiplication should be 0, then I will get 0. But if A and B is equal to 1, then I will get 1 at the output side. So this is the AND gate truth table. Here we can see this is the truth table of AND gate. Now next one is OR gate. Here we can see this is the OR gate symbol along with its Boolean expression, and this is the truth table of OR gate. Now similarly here, like AND gate, here we can see 2 inputs and 1 output. Now we can make it 3 input, 4 input and many more. So if I enter 2 input, so that means OR gate perform addition. Here we can see its Boolean expression is like C is equal to, that means output is equal to, it is A plus B, addition of these 2 inputs. Here we can see this is the symbol and here this is the Boolean expression of OR gate. Now through this Boolean expression we can derive this truth table. Here we can see this is the truth table of OR gate. If I enter 0, 0, that means it becomes 0 because it makes addition. So if I entered 0, 1, that means 1. If I entered 1 and 0, that means 1. But I entered 1 and 1. If its value is same, 1 plus 1, though it becomes 1 at the output side. Now I say here that it is the addition of 2 inputs. Now remember this thing, this is the binary. So do not make it 2. 1 plus 1 is not equal to 2 here in OR gate. So this is the binary addition, that's why 1 plus 1 it becomes 1. Right? So this is the OR gates truth table. Now let us discuss about universal gates. So here why it is known as universal gates? Because through this universal gates, by using NAND and NOR gate, we can implement all types of gate like basic gates or derived gates. So that's why it is known as universal gates. So here we can see NAND and NOR are the universal gates, and we can perform all types of gates through this universal gates like AND, OR, NOT, XOR, XNOR, anyone. So here we can see first NAND gate. So its symbol here, there is a some changes in AND gate. So NAND gate, that means it is the combination of NOT plus AND. That means it is NAND gate. So here we can see in symbol, this is the symbol of NAND gate, and it becomes true NOT plus AND. How? Here we can see NOT, that means it represents bubble. So there is a bubble. And AND, that means here we can see this is the symbol of AND. And combined we can make NAND gate. So that is basically inversion of AND gate is NAND gate. So here we can see there are two input A and B, and we can make it 3 or 4. So its symbol here we can see, and its Boolean expression is like output, or we can say C is equal to A into B, because AND perform multiplication between two inputs. So A into B complement, or we can say bar, A into B whole bar. So that means it is the NAND gate. Here we can see this is the truth table of NAND gate. So if I enter 0 0, that is in AND gate is 0, but here NAND gate, that becomes 1. If I enter 0 into 1, so in AND gate it is 0, but here it is 1. Similarly, 1 into 1 in AND gate, it becomes 1, but here it becomes 0. So here we can see this is the truth table of NAND gate. Similarly, here we can see NOR gate. So it becomes OR plus NOT. Here we can see this is the symbol of NOR gate. So it is the combination of OR plus NOT gate, it becomes NOR gate. So here we can see its operation, symbol, Boolean expression. So it becomes C is equal to A plus B whole bar. So it is basically inversion of OR gate. So here we can see this is the truth table of NOR gate. That means if I enter 0 0 in OR gate, your output will be 0, but here it becomes 1. 0 1 in OR gate, your output will be 1, but here it is 0. 1 0, similarly 0, and 1 1 in OR gate, it is 1, but here 0 due to this inversion. So this is the NOR gate. Now let us discuss about derived gates or other gates, spatial gates. So here we can see these are the spatial or derived gates. XOR, XNOR is also called as exclusive or exclusive NOR. So first XOR, here we can see this is the XOR symbol first. So it is like changed compared to the OR gate, because here exclusive OR, so there is a one line. So remember this symbol. Now it's Boolean expression. Here we can see if C is equal to A exclusive OR B. Here we can see one symbol between the A and B, that is known as exclusive OR symbol. So we can say A exclusive OR B, or we can say C is equal to A into B whole bar plus A bar into B. That is your exclusive OR Boolean expression. And through this expression we can make here its possibility. Basically, what is the meaning of exclusive OR and why it is known as spatial gates? Because it performs spatial operation. Because other gates perform various operations like addition, inversion, multiplication. Here exclusive OR not perform like that. It is like A is equal to B, then and then your output will be 0. That means if A is equal to 0 and B is equal to 0, then your output will be 0. Even though if your A is equal to 1 and B is equal to 1, then your output will be 0 as well. So this is special operation. That's why it is known as derived gates or exclusive OR gates. That means 0, 0, that becomes 0. 0, 1, that becomes 1. 1, 0, that becomes 1. And 1, 1, that becomes 0. So here you can see in truth table. So this is the exclusive OR. Similarly here, exclusive NOR. So basically we can say this is the inversion of XOR. So here we can see this is the symbol of exclusive NOR, and here we can see A exclusive NOR B. So its meaning is like A is not equal to B is equal to 0. That means if your A and B is not same, then your output will be 0. Here we can see in truth table. If your input is 0, 0, that means your output will be 1. Here we can see if your input is 0, 1, then your output will be 0. That means A is not equal to B, then your output will be 0. If your input is 1 and 0, then your output will be 0. Here we can see in truth table, if your A and B both are equal to 1, then your output will be 1. So this is the exclusive NOR gate. So today we discussed about basic gates. So these are the important for building of digital circuits. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.